Good morning, champs. Imagine mounting a shelf in your garage. A 15-kilogram toolbox sits on the shelf, and the shelf is held by a screw. The question is, can the screw hold it? Most people look at the weight. Engineers look at the moment. We are given a toolbox mass of 15 kilograms, a shelf mass of 2 kilograms, and gravity is 9.81 meters per second squared. The distances are equals 0.6 meters, B equals 0.1 meters, C equals 0.35 meters, and H equals 0.12 meters. We want to calculate the screw tension in the horizontal direction and the screw shear in the vertical direction. Small side note, the shelf center of gravity is not exactly in the middle because the shelf is not just a board. It also includes the bracket and the screw area near the wall. Since more material is close to the wall, the center of gravity shifts toward the wall. Now we draw the free body diagram. The toolbox weight acts downward. We call it FTB. The shelf weight also acts downward. We call it FS. At the lower wall contact, we have the wall reaction FW. At the screw, we have a horizontal screw force FSX and a vertical screw force FSY. Before solving, we convert masses into forces. The toolbox force is 15 kilograms times 9.81, which gives 147.2 Newton. The shelf force is 2 kilograms times 9.81, which gives 19.6 Newton. Next, we take moments about the screw, because the screw forces then disappear. Moment arms are always perpendicular distances. For the toolbox, the moment arm is a minus B. So the toolbox moment is FTB times a minus B. For the shelf, the moment arm is a minus C. So the shelf moment is Fs times a minus C. Using moment equilibrium about the screw, the wall reaction times H must balance both clockwise moments. Therefore, Fw equals Ftb times a minus B plus Fs times a minus C divided by H. This gives Fw equals 654 Newton. Now we use horizontal equilibrium. The wall force points to the right. The screw force was drawn to the right as well, so the equation gives Fsx plus Fw equals 0. Therefore, Fsx equals negative 654 Newton. The negative sign means the real screw force points to the left. Finally, vertical equilibrium. The screw shear must balance the toolbox weight and the shelf weight. So Fsy equals Fs plus Ftb. This gives 166.8 Newton upward. The results are wall force 654 Newton to the right, screw force in X direction 654 Newton to the left, screw shear in Y direction 166.8 Newton upward. The big lesson is that the toolbox weighs only about 147 Newton, but because of the moment arm, it creates a wall force of 654 Newton. That is why engineers do not only ask how heavy something is, they ask where is the moment?